In this example, we are looking at the convergence or divergence of the sum from n equals 1 to infinity of negative 1 to the n over 3 to the n. We can view this as the sum from n equals 1 to infinity of negative 1 to the n times a sub n, where a sub n equals 1 over 3 to the n. Notice that for n greater than or equal to 1, 3 to the n is a positive value. Likewise, 1 over 3 to the n is also positive. So that means we do indeed have an alternating series. In order to apply the alternating series test, we first need to look at the limit as n goes to infinity of a sub n. That is the limit as n goes to infinity of 1 over 3 to the n. And as n goes to infinity, 3 to the n also goes to infinity, so we have a 1 over infinity determinant type, which tends to 0. Next, we need for the sequence we are adding together to create our series to be non-increasing. That is, we need a sub n plus 1 to be less than or equal to a sub n. Well, a sub n plus 1 means substitute n plus 1 into our formula, essentially, for a sub n. That is, we have 1 over 3 to the n plus 1. Using properties of exponents, we can write this as 1 over 3 times 3 to the n, or 1/3 times 1 over 3 to the n. That is, we have 1/3 times a sub n. Now, since a sub n is a positive value, when we multiply it by 1/3, we decrease in size. So this is less than or equal to a sub n, which meets our second criterion for the alternating series test. So since the limit of a sub n goes to 0 and the sequence a sub n is non-increasing, we can conclude by the alternating series test the sum from n equals 1 to infinity of negative 1 to the n divided by 3 to the n converges.